In this video, I'm going to go over the basic shapes of exponential and logarithm graphs and how you can recognize these in problems. So I'm going to start with the basic being the natural logs and the natural exponent, e to the x, and ln x. So if we want the graph of ln x, it's always going to look like this, where you have a vertical asymptote at x equals 0. You always cross here at the point 1, 0. And because it's natural log of x, you can see that if you plugged in e for x, you should get 1. So up here somewhere you have the point e, 1. Everything else is just a matter of plugging in, but that's the basic shape. Now for the exponential, the natural exponential e to the x, it looks like this, where you have a horizontal asymptote at y equals 0. You always cross through the point 0, 1. And again, since we have e to the x, if x were 1, e to the 1 is simply e. You always cross through the point 1e. So you can see something is very similar about these two graphs. In fact, ln of x and e to the x are inverse functions, so their graphs show an inverse relationship. If you reflected either of these graphs over the line y equals x, which is how we graphically determine inverses, you would get the other graph. So keep in mind, any transformations that you learned maybe in pre-calculus, shifting left and right, shifting up and down, stretching and compressing horizontally and vertically, can be applied to these graphs in a variety of manners. So you just need to make sure that for ln x, you know you have a vertical asymptote at x equals 0, and for e to the x, you know you have a horizontal asymptote at y equals 0. So if this graph is shifted, the horizontal asymptote goes with it. Or if it's reflected right now over the y-axis, the vertical asymptote would not move. But if it was shifted and then reflected, it would move. So those are things you need to take into account. But just knowing the basic shapes for logarithm and exponential graph is going to help you a lot on the tests.